Hi boys and girls, it's Thursday and it's at the end of our work week, and so we're going to get started on our DMA day 4 for Thursday. So let's get started with our first problem. You'll notice our first problem has to do with perimeter. So if you remember, perimeter is the length of the sides of the figure. So we want to know total length of all the sides to the triangle. So we have 3 centimeters for that side, and the length of this side is also 3 centimeters, and the length of this side is also 3 centimeters. So when we find the length of all 3 sides together, we would add 3 plus 3 plus 3, since they're all equal, and we would say that this would be 9, and they do give us our unit of measurement, so this would be centimeters, so 9 centimeters in length. Now, we could also write this, since this is adding the same number over and over again. We know that's repeated addition, and repeated addition is related to multiplication. So you'll notice we have 3 groups of 3. So we could also show our perimeter as a multiplication equation. So 9 groups of 3 centimeters in for each side would give us 9 centimeters. Okay, so now let's move on to our word problem here. And we actually have 2 word problems today. This one is a one-step word problem. So we're going to take a look at this word problem, and it says John has 24 books to place equally on 4 shelves. How many books go on each shelf? So, thinking about our information, we know that we have 24 total books. We're going to put them equally onto 4 shelves. So what does that mean for our operation? The operation we are going to use is division, since we're going to take the books and put them equally onto the 4 shelves. So if we use a bar diagram, and I'm going to move my paper here, I have 4 shelves, and each bar is going to represent the 4 shelves for the bookcase. And I have a total of 24 books that I'm going to share equally between the 4 shelves. Now, I could start off by writing and drawing tally marks until I get to 24 to see how many books would be in each or on each shelf. But if we know our multiplication facts, we know that we have 4 shelves, but we do not know how many books are going to be on each shelf. So that's our variable. That's what we don't know. That's our question mark. So I'm just going to put a B here for books, since I don't know how many books are going to be on each shelf. And we do know, however, that that's going to be 24 total books. So now what I can do is use my understanding of multiplication to find how many books will be on each shelf. So I have 6 plus 6 is 12, plus 6 plus 6 is 12 again, and 12 plus 12 will give me 24 books. So we would be able to say that B is the same as 6 books on each shelf. And there's our model for our word problem. So now we're going to, I'm going to put a B in here since those are books. The B is representing the books. Now we're going to move on to our pattern problem. So real quickly, we're going to look at the numbers in this pattern. So we notice we've gone from 97, 92 to 87. So that tells us that we are subtracting since our numbers are decreasing or going down each time. We've just got to figure out how much are they going down by, or what's our difference between each group of numbers. So to get from 97 to 92, or we could think about how do we get from 92 up to 97, that would be a difference of 5. From 87 to 92, 87, 88, 89, 90 is 3 plus 2 more, again, would be a difference of 5. So now that we see that the pattern continues between these two sets of numbers, we know that our rule for this pattern is to subtract 5. So that's what we're going to continue to do every time. And so now we're going to take the 87 and subtract 5 from 7, and that would give us 82. We're going to subtract 5 from 82, so I could subtract 2 and then 3 more, which would give me 77, and then I could subtract 5 from 77, and that should give me 72. And if I were to continue this pattern, we would start to notice that the ones place has a repeating pattern in it. So if I were to continue, this would be 67, 62, 57, 52, and so on until we, of course, end up at 0 or in a negative numbers, which is a possibility. Now let's go on to our larger word problem. And this word problem is a two-step word problem. So let's take a look at our problem. It says, Blaine, Bobby, and Brian combined all of their toy cars. The word combined tells us that we're putting together all the cars. So what does that tell us we're going to do as far as an operation goes? Well, we're combining, we need to add. So we're going to take Blaine's cars, Bobby's cars, which is 21 and 35, and then we're going to take Brian's cars and add those to the other cars to get a total number of cars. Then it says they wanted to donate their toys to 9 friends, which means they probably want to give each friend the same number or same amount of cars equally. So that means we're sharing. So that means we're going to take our total cars and we're going to divide them equally. So I'm going to move our paper over here, and I'm going to show that we have Blaine has 21, and again I'm labeling my equation. I'm taking Bobby's cars, and I'm adding Brian's cars also, and I'm labeling that with Brian. So quickly, using mental math strategies, I have 20 and 30 makes 50, plus 10 makes 60. Ones place, 1 and 5 makes 6, and 6 and 6 makes 12. Now, knowing that my 10s are going to be added here to the 60, that 10 is now going to be 70, and I have 1s, which is 2. So this is 72 cars. Now we're going to take the cars and divide them equally between the 9 friends. So I can use what I know about and so this would be if I were going to represent this as a bar diagram, there would be 3 bars in my equation for our addition sentence. Now, in this case, we want to share these cars equally between the 9 friends. So I have 1, 2, 3, 4, 5, 6, 7. And I'm going to zoom out a little bit. 8 and 9. So I'm taking the 72 cars and I'm dividing equally between the 9 groups or the 9 friends. And I want to know how many cars each friend is going to get. So I'm going to put C for cars there. So if I take the 72 and share it equally, and if we know our multiplication facts, we know that blank times, or we have 9 friends, but we don't know how many cars for each friend, but we do know that there are 72 cars. So again, using our understanding of multiplication, this is why it's so important to know your multiplication facts, we would be able to say that there are going to be 8 cars for each friend. Remember, tally marks and dividing the tally marks equally isn't as efficient anymore. It's a little more efficient to be able to use your understanding of multiplication to solve for division. So we are going to have 8 cars per person, and so that would tell us our solution. So it's the end of the week, and we will have a DMA week 32 for next week. So have a great weekend and see you Monday.